Hi, my dear. Uncle Jimmy. How are you? My dears, continually chapter 9. Flow in closed canals under pressure. Part G. Flow through a pipe has multi-analogous outlets. Multiple outlets occur when there is several nozzles discharged on a pipeline at the same time. Hence, head losses differ as the case because the main upstream discharge and also flow velocity are decreasing gradually along the pipeline, such as sprinkler and micro-irrigation feeding lines, as shown in the enclosed equation. The identification of perimeters in the previous equation. Table showing coefficient vector values f at m value equal to 1.852 according to Hazen-Williams equation. Look, my dear, by yourself. This look. Table showing coefficient vector values f at m value equal to 1.9 according to Scopy equation. Table showing coefficient vector values f at m value equal to 2 according to Darcy-Weisbach equation. Normally, and logically also, changing of pipeline diameter to a smaller size being used downstream because the charge and hence flow velocity also are decreasing gradually along the pipeline while requiring to increase it. So, the total head losses can be calculated as is case as shown in the enclosed equation. Generally, and at all cases, it is very important to take the land elevation either up or downhill into consideration when calculating the pressure head along the pipeline. Anyway, pipe laterals considered at the same time as feeding lines as case of sprinkler irrigation, while the feeding lines are different as case of micro-irrigation method, as it consists of polyethylene hoses branching from the pipe laterals and so involving distributors fixing by either online or inline. Head losses along that feeding lines which have online distributors can be determined exactly by the same previous equations of multi-outlet pipeline, while at case of inline distributors in drip irrigation system consider practically a type of multi-contraction and also enlargement along the line run. Hence, an additional minor head losses must be taken into consideration, which mainly depend on the type of distribution, discharge, number, and also the inner diameter of polyethylene feeding line as shown in the enclosed table. Table showing minor losses per meter at case of inline feeding polyethylene lines in drip irrigation system, at case of distribution charge 2, 4, and 6 liter per hour. Table showing minor losses per meter at case of inline feeding polyethylene line in drip irrigation system has distributor discharge 8, 10, and 12 liter per hour. Look and take care, my dear. It is a very important subject which will assist you to design an irrigation system practically in the field. As example, calculate the head required to overcome the pressure losses through 1,500 meter length of different PVC pipe carrying a discharge of 150 cubic meter per hour of water. Take into consideration it has slightly rounded entrance, 5 standard bends at 90 degrees, 2 fully open gate valves, and 1 90-degree standard elbow. Also, concrete the preferable use size. What you can do? Look to the solution. You must calculate the charge first per cubic meter per second. Referring to tables, you can find the thickness of PVC pipes. Hence, detect the inner diameter. Calculate the flow velocity for each choosing pipe diameter, and calculate the Reynolds number according to the enclosed equation. Table showing nominal diameter, wall thickness, and weight under different working pressure for plastic PVC pipe has nominal diameter from 10 up to 160 millimeter. Table showing nominal diameter, wall thickness, and weight under different working pressure for plastic PVC pipes has nominal diameter from 180 up to 800 millimeter. Table showing nominal diameter, wall thickness, and weight under different working pressure for high density polyethylene pipes. Table showing nominal diameter, wall thickness, and weight under different working pressure for low density polyethylene pipes. The identification of previous samples on calculation Reynolds number in addition to calculation of friction factor. My dear, deduce fitting equivalent length of the second losses as shown. Hence, the total effective length will be deduced also as shown in front of you. My dear, the best way for simplifying and presentation the result of previous calculation. Finally, calculation the head losses through each pipe can be done according to Darcy-Weisbach equation as shown in the enclosed equation. Hence, you can choose the preferable diameter used as scale and also calculate the head required to overcome the pressure losses. Goodbye.